As you can see on my laptop when I record videos, I don't have the hotkey set up, so I gotta do this scrolly thing. It's lame, but hey, it's kind of fun to see how I'm doing that. Anyway, okay. So continuing along with our theme of the potential dangers of inheritance, I want to give I talked about this very briefly in a previous lecture, but I want to remind you that extends should only be used for is-a relationship, like literal hypernymic relationships. It's a very common mistake to use inheritance, at least here for a novice programmer, for has-a relationships, which is also known as a meronym. That is, it's possible, let's say you want to write a set class, you could make it extend slist. And every time you do add last, it checks the entire list to make sure it doesn't already exist and only adds it if it's not already there. That would be in some sense a set. But it's also strange because a set isn't an slist. There shouldn't be a get method. So at least sets, as we think about them in Java, there's no specific order of the items. It's just a collection. So having a get method doesn't quite make sense because sets aren't order. You can't get the third thing because there is no third thing. It's just a set. Okay. So that is an abomination, I guess, to use strong words, as noted here on the slide. By contrast, what we had earlier, the vengeful slist, that did make sense. It really was an slist. It had an additional capability, but it wasn't always an slist. Now this might seem a little silly, but I want to give you a real-world example from Java itself. So let me introduce to you a new abstract data type called a stack. Okay, so a stack has two operations, push and pop. So let's imagine the stack has 4 right now. If I push 6, it appears here. If I then push 2, it appears there. So you can only add to the top of the stack. And then when I pop, we remove the top item. Okay. So it's a very simple idea. Has a lot of utility, as we'll see when we get to talking about graph theory especially. Stacks are a very useful idea, much more useful than you might expect. Plays into computer science theory in some interesting ways. But the Java designers, they made a serious mistake when they designed the stack class, I think back in Java 1.0. I'm pretty sure it was 1.0. So they decided when they implemented it that they were going to use the extends keyword. And they said, well, we already have this class called vector, which is an array list, basically. It's just a variant of the array list. You can read about it if you want. And they said, well, a stack is basically an array list. You push and pop only from one end. So they made a class called stack, which extends vector, which had a push and a pop operation. But that means that java.util.Stack, the built-in stack class in Java, has all of the list operations, which is pretty annoying. That is, a stack is supposed to be very simple. It's supposed to have a push operation, a pop operation. You could throw in a size operation if you'd like, and probably nothing else. And we could have simply implemented it like this way. We have a class called stack that has a linked list that stores the data. So when I create a stack, we get a new linked list. And this is a piece of syntax you may not have seen before, where instead of having a constructor, I could just instantiate a variable at the time of declaration. This also works in Java. Whenever I push, I add last. When I pop, I remove last, and size returns the size of the items. That's it. This is all you'd need. This is a very bare bones implementation. A stack has a linked list. But because the Java designers said stack extends vector, that means that a stack has all of these other operations. It's not just a nail clipper in this thing for cleaning out under your nails. It has everything you might ever want, and that's just not a useful class. So it has push, it has pop, add, contains, elements, ensure capacity, get, insert element at, remove range. There's more. I couldn't even fit them all on the slide. And as a result, whenever you use a stack, you run into potential danger. You're giving the programmer too many options. If they're using IntelliJ, the autocomplete is going to suggest all kinds of crazy things, which could cause you problems. Maybe it doesn't. Maybe it does. But for this reason, I find the Java stack just distasteful. It's got too many abilities. And this is just a side effect, a danger that if a novice programmer, like the folks who were designing Java back in the day, I don't know how novice they were, but they made this serious mistake. So implementation inheritance can be a problem. But we'll see in the next couple of videos that it can get even worse than just having extra tools that you maybe never use.